Ladies and gentlemen, it's a pleasure to introduce our next speaker for today's conference. With over 16 years of invaluable experience in Linux development, our first speaker, Kirti J, is a true luminary in the field. As a member of the technical staff, Kirti has contributed significantly to the industry, crafting application notes and collaterals that have been instrumental in guiding and unblocking numerous customers during various stages of product development. Joining Kirti on stage is also Prasad Jondale, a seasoned systems architect with over 12 years of expertise in solving technical challenges on the embedded systems environment. Together, they will unravel world of tools that play a pivotal role in product development, showcasing the vast array offered by TI and its esteemed ecosystem partners. Please join me in welcoming Kirti J and Prasad Jondale to the stage. Thank you.
Welcome back. Hope you had good lunch. No response. How was the lunch? Thank you. So, yeah, I'm Kirti. I'm with TI for the last 16 years. Predominantly worked on Linux, power management, thermal management, PMICs and whatnot. So, I put a lot of things to sleep, but not today, hopefully. So, yeah, currently I'm playing the role of applications architect with the Jacinto Software Apps team. So let me start off with a quick round of agenda. There are at least 3 to 4 speakers who have shown TI SOC portfolio, but I still want to show that portfolio because I want to show how we scale in the software side of it. Then I'll go to the SDK offerings on all the 3 families of TI processors. And then I will go through the Linux specific tooling, and Prasad will cover the RTOS side of things. Okay. So yeah, so we have a very wide spectrum of SOCs, starting with a single ARM M0 at the lowest and ultra low cost MCU. We then scale up to the mid-range MCU with C2000, and then high performance MCU with AM62. And then we have the low-cost MPU with AM62, and at the end we have the high-performance TDAs, which we saw the demos for. Similarly, we have SDKs that scale across all 3 families of TI SOCs. Starting with, we'll start with Linux. Linux is, of course, the HLOS, so it caters to Jacinto and Citara MPU. The Linux is mostly for flexibility and end applications that don't need any real-time, hard real-time deadlines. The RTOS SDKs across the portfolio of processors, Jacinto, MPU, and MCU. Then we have soft real-time, basically the RTOS, the Linux real-time flavor, which caters to soft real-time. And then we have industrial communications across MCU and MPU. This is to develop RTOS and non-RTOS applications on the programmable real-time unit, which is the PRU. When you go to the TI.com site, you will see device-specific SDKs for all for every single SOC. So that doesn't mean that every SOC SDK is different. Underlying underneath it, the whole set of Linux SDKs have the same Git repository. We just package them to cater to very lean and mean SDKs for each SOC. So, and all of these SDKs are completely open source. They are all available on TI.com. All the source code is open and free. Moving on. So typically, so I'll start with Linux. So typically when a customer starts off on Citara MPU or Jacinto, they want convenience, they want flexibility, they have their own bootloaders, they have their own boot media. So the preferred choice of OS is Linux, and it's completely open source. Yeah, so the journey somehow starts with customer procuring the EVM. And we go to TI.com for a specific SOC. We search for a specific SOC where we have software support. We start downloading the SDK. And once that is downloaded, we support build on the Ubuntu Linux machines. We build the SDK. And then we use one of our choice of boot media, be it UART or USB DFU or simple SD card. We put all the download all the binaries, and then we boot the binary, and we sort of run an out of the box demo and to get a feel of what the SoC is capable of. So till now, it's all hunky-dory. Everything is taken care of by TI.com. But then when we move to custom board, you have plethora of tools that we support from TI side for each stage of your custom board bring up. So now I'm totally talking about Linux side of things. I'm speaking from the Linux world. So there are so many tools that are there to help you to develop your application on your custom board. So I'm not going to go through each of these tools. So I'll categorically take up the ones that are really powerful and yet simple to help build your own custom application on custom boards. So anything with custom board starts with PinMux configuration. The first thing that goes wrong is mostly PinMux configuration. So we at TI have developed a very simple graphical user interface based tool called sysconfig. So I'll not go to run through this list of features that it supports. So in a nutshell, it's a simple tool, graphical user interface based tool, GUI based tool, and we can install it on Windows or Linux. And there is also a browser based tool which we can use to set our PinMux. So what is so special about this setting PinMux using this? You just go to the PinMux web page. I've chosen the web tool here. Say you want to configure PinMux for a particular instance of I2C. There's a drop-down menu. You just go click on them, pick them. And these pins can come out on multiple balls. You choose whatever is there on relevant to your custom board, and then you get the source code. So that is the beauty of the tool. So you don't need to even write a single line of PinMux configuration code. You just get it ready-made as soon as you pick one of the proper pins from that pertains to your custom board. So this is for people who are aware of Linux. This is the device tree code. So we get ready-made device tree code out of this tool. This is a simple demo that I've prepared. This is the sysconfig tool. You select the SoC that you want, then say start. So the sysconfig is setting up the environment for that particular SoC in the background. Now there are all the peripherals that are listed here. I picked I2C, and then there are multiple I2C instances. I picked the first instance, and then you need to pick the ball where the pin comes out on your EVM, and then click on these. These are the source code files, essentially. You directly get the device tree code. You can just copy paste to your custom board DTS. And also, this provides the RTOS side of code as well. The J721E pinmux.h, this is the RTOS code for pinmuxing. So now, we are done with, say, pinmuxing. Let's start this journey of custom board bring up using Linux. So we are done with our pinmuxing. So people who have used Linux, so now you have a SoC, you have configured your pinmux, say, assume you have configured the right PMIC as well. What stops you from booting Linux from SoC to Linux? What is that in-between thing that you face most of the times? What do you need? Sorry? Thank you. Okay, so the next problem or the next challenge is to pick a right DDR part. So as a TI EVM, we'll have one of the DDR parts, but most customers will not really use that DDR part. And DDR configuration has a lot of registers. So it is not a day job or a simple job. So for that, again, we have tooling. That is the DDR register configuration tool. I'll go through this now. So it's a pretty simple Excel-based tool wherein there are 3 inputs to this tool. So there are user input is just 3, and there are outputs in various forms. The configuration is basically the configuration tab expects you to put the right SoC, the number of DDR parts or the controllers that you have, whether you have enabled interleaving or not, and a bunch of other parameters. And then the DRAM timing part, this is where you need the custom DDR part data sheet. You have to fill in a bunch of parameters from the data sheet to this tool. And then finally the I/O control, the desired I/O settings such as drive strength and termination, etc. That's it. You are done with the DDR configuration. Now so this tool is so flexible. So based on whether you are using a Linux SDK or RTOS SDK, or you want to first check the configuration using some debugger like CCS or even Trace32, all of these are possible. So the output will come up. This is just a snapshot of the output of the tool. You can use any of them. So for Linux, we use the DTSI, basically the device tree. So there's just a very small portion of the output. This runs up to probably 1,300 register settings. So TI makes it very, very easy to configure a custom DDR. So I think, gentlemen, you had a question like if we are using a different component outside the EVM for a custom EVM. So be it DDR, we have this tool which will help you configure your custom DDR on your board. So this tool is very, very critical. So now we have done with the DDR configuration. We'll start booting your custom board now. So we want some sort of debugger. Linux, there is a very good support for Linux from the Lauterbach. That's a standard debugger. Trace32 is the software interface. So this is a very popular debugger. CCS is also very popular for TI SOCs that Prasad will be covering. I will talk about Lauterbach, that is the Trace32. So you can just go and Google for Trace32 and any of the TI parts. You will get ready CMM scripts. That is, the CMM scripts are the configuration scripts that are used to connect to an SOC through this Lauterbach debugger. So it pretty much connects to all the ARM cores, be it real-time R5Fs or the A cores or whatnot. It has very powerful scripting language. You can pretty much do everything. And as covered in the previous tool, the DDR tool also gives you CMM scripts to configure your custom DDR using this tool. And there's a very good support for source level debugging on multiple OSs. So the tool is aware of OS, so you can actually do source level debugging for Linux, QNX and whatnot. So pretty much all the TI SOCs are covered with this tool, so we can really debug very nicely with this tool. And yeah, so typically the Linux boot flow is, we use the SPL U-boot. I'm not sure how many of you were really engaged with Qasim's presentation. He was presenting it beautifully with the U-boot. That's the open source bootloader that we use for Linux SDK. So with that, we can use, you put infinite loops in the beginning and then step through and make sure that everything runs, and then we can get to Linux with this tool. Now the custom board has come all the way to Linux. Now you start running demos like that. So for all the demos that you're seeing there, the foundation is these SDKs and the tools that we offer here. Moving on, now that you have booted your binary or your Linux or your QNX kernel, the next thing is you want to run applications and you want to check what is the system state. So we have something called, a tool called K3Conf. Don't be confused by the name K3. K3 stands for Keystone 3, from which all the J7, Jacinto 7, TDF4 and all the AM6 platforms are derived. So this tool is common across all those SOCs. And this is available for both QNX and Linux SDKs. There's a quick, so there are a lot of features that K3Conf supports. So Linux savvy people like command line interface. So this is a command line tool. There are a lot of options that it provides. So you can, at runtime, you can actually start with as simple as reading a SOC register to writing to it. Then you can actually dump all the device states, all the peripheral states at that time. You can check what is the clock rate that is programmed at runtime. So there was one question on what is the frequency of C7X that it is running on the TDF4 demos. This tool is a one-line command, and you'll get the frequency of the DSP. And then they have commands to enable the device, enable a peripheral runtime, and then to disable them. One small demo of that. So yeah. So this is a completely command line based tool. It has a lot of options like enable device, enable clock, disable and disable clock. So I just typed K3Conf dump device 202 is basically the A72 core, and it says the device status on. Of course, it's running Linux, and K3Conf is actually running on Linux. You can see that we could even dump the clock rate frequency. It's 2 gigahertz. In general, you can use device to check what devices are on and what devices are off. So yeah, it makes your application development that easier to check state of your devices at runtime. Okay, with that, I think I'm done with all my slides. Yes, I'll let Prasad take over the RTOS side of things, and then I'll get back for questions. Thank you.
So already has made, getting started with Linux very, very simpler. All good, but it makes our, the RTOS guys' life very difficult because, internal competition and all, but they are like, hey, we have done with Linux. You can't even do with the RTOS. So, oops. Okay. So see, he already made my life difficult. Okay, so we'll be getting started with the RTOS and bare metal NoOS. During the lunch, there were a lot of questions like, hey, we like your SDKs, we like your examples, but a lot of baggage comes. Like, I want to develop without the operating system, but, there is a BIOS start. That's why we added this bare metal to NoOS in the presentation title, because all our offering actually, is consistent, compatible between the RTOS and bare metal NoOS, whatever you call. Quick intro about myself. The photo is 6 years old. After that, I never looked good. So I'm a software architect in the Processors Platform Software Organization. Been in TI for more than 10 years, have been working on the networking systems. Last 2-3 years, I've been working on the microcontrollers. My real identity is I'm the guy who is sitting between sleep and the lunch and the sleep. So at least in the Qasim's case, you had a incentive key, you had to go for a lunch. So you were laughing at, all his not so funny jokes. Come on, apart from first, others were okay, right? So, all right, so my intention here is, not to make you go sleep. When we were discussing this with Anshu and all, they were telling, yeah, you keep it interactive, people would have a heavy lunch and all. And we tried to do that, but I didn't realize one thing, you call it missed requirements, that how do I keep myself awake, okay? So now it is up to you to keep me awake. All right, so we do have very interesting stuff, so hopefully nobody will be getting to sleep. Okay, so what are the building blocks of the RTOS getting started, right? So if you see, and already you saw with the Linux itself is getting simpler. Now for the microcontroller customers, where the software investment is limited, right? So the getting started, ease of use is very, very fundamental. And we know if you have to succeed in this business, there is no way but to keep things simpler. So that is the design philosophy in all what we do with our RTOS offering. And even though I would be speaking on mostly from the MCU Plus perspective or Citara MCU, but as we discussed earlier, this applies to all the RTOS cores. So basically RTOS cores on the Citara MPU, RTOS cores on the Citara, Jacinto side. So the 4 building blocks, if you see, and this is the stacked WAN, this is how our software offering, our offering is built. So at the core part of the stacked WAN, you can see the GUI config tools. So basically, to minimize the time to get started, to minimize time to, basically do the configuration and, SOC related part, and focus on the application development. As a user of our chips, you are more interested in developing the application on the chip, not doing the device configuration, not doing the pin mux, and not debugging the simpler I2C and SPI issue, right? So what we have tried to do, basically enable wherever possible the GUI configuration tools, be it a sysconfig which we covered, or the DDR config for the MPU class of devices. So there are lots of tools. I'll cover in the separate slides. So based on the tools, we have developed the MCU Plus SDK, which is our default RTOS SDK across all the processors. So MCU plus SDK actually is our drivers and libraries and stacks. Again, the same philosophy, keeping things simpler, making things intuitive. So we have, next in the line is the MCU plus Academy and the design gallery. So basically now we have tools, you have the SDK, you want to get started, right? So typically we prefer getting started with the instructions, right? Hey, you do this, you do that, check now whether LED is blinking. Kasim was taking example, we still do that. Or, whether A is on the UART character. So basically Academy actually are a collection of these tutorials. If you like the quizzes, there are quizzes at the end of tutorial to assess your understanding. And the design gallery is where we keep all our reference designs. Getting a little bit outside again, the TI Resource Explorer, we call it TI Rex, is basically one-stop shop where we host everything. So in fact, not only related to the MCU or the RTOS, the Linux or any other offering from our side is actually hosted on the TI Resource Explorer. So these are the 4 building blocks of our offering, RTOS offering, but applies pretty much to everywhere, and we'll be getting into each of these. Okay, let's zoom a little bit into the TI Resource Explorer. So if you see on the left-hand side here, getting started with the RTOS is just a 2-step, not many, okay? You order the EVM or the Launchpad, go to Academy, and that's all. Okay, I was kidding, there are many steps. But I promise, it is still simpler. Okay, so once you go to this link, right, you will be presented with this view, which is the TI Resource Explorer Cloud View. So again, all our tools are available on the cloud, so you don't really need to order. In fact, we are saying the step 1 is the order the EVM, but you can do a lot of analysis even on the cloud, explore and find out what examples, what reference designs has been enabled. So if you see, it hosts actually the Resource Explorer, which actually has a device documentation, which has a DMs, the TRMs, the app notes, white papers, anything and everything related to that device. So we have the embedded software, basically the SDKs, or any other software, basically the demos we have enabled, anything which comes from our 3P if they are hosting it here, right? And it is very easy to navigate, right? So you go to the SDK, just click download to install, the SDK will be downloaded, on your PC. So if you want to actually point to the specific example and then start from there, just go to that particular example. You can explore all the examples available. You can see here, there is a MATLAB, networking, real-time debug, real-time control. Whichever you want, wherever you want to get started, just click on that, import that to the CCS Cloud ID, and you can get started. That's it, pretty much. So moving a little bit next, staying on the TI Rex only, but the CCS integration. Now again, we fully understand, right? Like basically, a lot of our customers prefer the IDE-based development. Everything is in IDE, like your development starts and ends at the IDE. So the TI's famous Code Composer Studio, right? And again, based on the open source Eclipse, so you don't need to learn anything just to get started with the CCS. So the TI Resource Explorer is also integrated on the CCS. So once, let's say you downloaded the CCS, you go to the view menu, and you are presented with this view. Now the one interesting thing here, right, you have a board ordered and connected to your PC, right? Now you don't need to do anything, right? Typically you have to go and configure the device, detect, all that stuff. All you need to do is just detect your board. So there is a detect functionality. It will go and detect based on some hidden magic. It will detect that board for you, and it will bring all and everything related to that device for you. So one thing we typically struggle, right, and you will agree with me, that is the information overload. Oh, yes, TI has a lot of documentation. Yes, everything is there, but I'm not able to find. Okay, I go to E2E and, then I have to ask questions. Here, anything you want for this device is here. Again, as I said, TRMs, DMs, SDKs, reference designs. So now you explore here and just download whatever you want. The SDK could also be downloaded from here. So the TI Rex is your starting point, and I would say pretty much you can just do everything you want with the TI Rex. Moving on, let's move to the MCU plus Academy and Design Gallery. Again, this is the TI Rex or the cloud-based. So if you need to explore and, you know, find out if there is something which suits your application, you can just go there. So there are, the philosophy here is, right, to you evaluate with the MCU Plus Academy. Just explore the SDK, what are the building blocks, if any offering is matching your expectation, and then integrate with the design gallery. So design gallery, I think many of you who has been working on the C2000 devices, right, would be aware of our TDAs, TI designs, right? So basically many customers actually has gone in production with those designs, right, using those devices, using those reference designs. So we host basically on the design gallery, we host every reference design we have. And again, I think you would have realized by now, we really believe in the keeping everything on the ti.com. Everything is open source. In fact, sometimes I don't like, you know, why to make everything available for our competitors, right? But anyway, I stopped fighting that battle long back. So if you see the design gallery, overall you can see and I am showing the snapshot of the 2.6, which is our real-time control devices. You will see the traction inverter demo, string inverter demo, and I think this is a solar one. I'm not able to see it. And of course, after you explore there, you can build using the tools we are providing, the sysconfig, Flash, GUI Composer, and all. Moving on, just a little bit into the MCU Plus Academy. I won't go into detail, but again, list of tutorials divided into the fundamentals and advanced. So based on, you know, your learning level, you can take the tutorials, learn about the SOCs, learn about the TI processors. All right, we covered the TI Resource Explorer, one-stop shop. Then the Academy and Design Gallery, where we host our documentation and the reference design. Let's move to the MCU Plus SDK, and MCU Plus SDK will take its maybe one day seminar just to get into details, right? So, of course, I won't be covering all the details. So, two things I want to focus here or bring your attention. The first is the tools. The focus has been on the tools. And you will see that, in fact, there is a tool for every functionality now we have. If you take security, there is a tool. If you take safety, there is a tool, right? For configuration, for FreeRTOS, for the flashing. The next is the open source ecosystem, and I noted Qasim saying, right, yes, Linux, everything open source, you can get used to that, and you know, you can learn from the community. But now you learn the MCU Plus SDK because you know it comes from us, and there are certain things. Yes, that's partially true. Because even in our RTOS SDK, we're trying, our focus is using the open source ecosystem versus the proprietary ecosystem you have, right? And that's where all the middle layer you will see, or the most of the middle layer you will see, it is taken from the open source. The tiny USB will be aware, like USB stacks, LWIP for the TCP IPs, right? So the focus has been, you know, utilizing the community, contributing to the community. Okay, last in the list, the number of tools, and I just want to show like the kind of tools we are building here across the different stages of development, whether it is SDK tools like a CCS IDEs and SDK Composer and the TI ARM-CLang, right? The device configuration, we will discuss a little bit about sysconfig. Now one challenge you typically see, right? Hey, you know, you have 2 megabytes of SRAM and you want to split across multiple core, right? So it becomes difficult because you have to go to the linker command file, you have to understand linker command file. Why? There is a linker command file tool and it's very intuitive, right? So the lighter blue or the sky blue are actually being in development or in planning. Now others are all available. Okay. All right, so just the two tools I would be discussing here. One is the sysconfig. Kirti already touched about a little bit on that. But what I want to focus or bring your attention here is the sysconfig for the RTOS. You know, so if you see on the left-hand side again here, there is a Hello World project, and the file is example sysconfig, which is actually integrated in each and every example. So basically, all the tools we are developing, again, there is a you know, proper attention paid that, you know, it is nicely integrated to the application. So this, every example which comes with the MCU Plus SDK has an integrated sysconfig. So you pick any example. It's not like, hey, you know, there is only reference design you can pick and start with that, and now you have to do a lot of porting work and all. No. the sysconfig is integrated everywhere. Just to see, just to little bit give a further overview of the tool, right? It has a different tab. It shows all the modules available in the SOC. So you would be able to see, right? Like there is a FSI, GPIOs, I2Cs, MaxSpice, and all these are all the peripherals available on the SOC. This green tick box is actually the peripheral being used in this example. So because this is a hello world and no price for guessing, we are using the UART for the logging purpose. So UART is being used, and of course there is a clocks and the MPUs and whatnot. So as and when you make the changes, the change is right away visible on the right hand side. You can see this is the code window or the code tab. So if you make changes, it is right away visible, and you can see like, hey, if you are making the right change or not. Additional feature of the sysconfig is, you don't have to go to compile time or run time to catch some of the errors. So the pinmux which we saw in the earlier presentation, right? What if, and this is a very common problem, you will resonate with me, that we actually configure the same pin, across two things. And now, one of the difficult debugs I have done, one of them would be the pinmux, So you don't need to go all the way till the debugger and the K3conf and, the CCS IDs to debug that. The sysconfig will just catch it for you because it knows what pin is already configured, and when the next time you configure it, boom, there is an error. It shows, hey, you have already configured. And it will also point you to that, hey, you have configured this pin in XYZ application or at XYZ point. So overall, again, utilize this feature, give us feedback if you see any improvements are needed. This is an in-house developed tool, so we can utilize that, and if there are any improvements, we can always take. Okay, this was probably I should have used earlier. All right. Okay, next and the last here is the Code Composer Studio. I want to say that the Code Composer Studio doesn't need any introduction. You would have used this, or if any other, for that matter, the Eclipse-based IDE, right? It's pretty much same. So as you can see, there is the application project which we can import. And I have seen like customers importing the application projects or projects from the other platforms. So there is a, you import the application, configure application using sysconfig. So if you have a hello world and you want to make changes, you want to see if your board is working. So basically change few things, change the UART instance using sysconfig and just, rebuild and load. So again, nothing fancy here, just whatever the typical ID should be providing. Okay, I'm doing good on the time. All right, coming to the conclusion, this is for both Linux getting started as well as RTOS getting started. Again, repeating to the point that it is becoming probably annoying, but each and everything we have is actually hosted on the TI.com. So sometimes, few things are not internally available, we go and get from the TI.com. And again, it is all royalty free. Of course, there are some 3P components which Qasim mentioned, where you need to go through some licenses. Leverage the tools and, realize the really cool applications. Of course, there are already the existing application you can just further improve. And for any help, please post your query on the e2et.com. So these are, one of us actually would be responding there. So in fact, I think Kirti may be responding 10 to 20 E2E queries per day, or maybe more. So you get a response from the real engineer, not somebody sitting somewhere. That's all from my side. Thank you so much. So,
yeah, that sysconfig for DDR configuration. Yeah. Yeah, there, when I see the forum, that RAM tuning, it is told like it is taken care in the driver. No need to worry. But if you see the data sheet of DDR, it will be min, max, or typical something.
Okay.
But if the driver we will see the data sheet and we will put some nanosecond or those parameter we will put. But which one is the optimized way to handle? Is it taken care in driver or how? Or after RAM tuning, how I will know what is set? Is anything I will get it back from that sysconfig?
So first thing is I would request you to go through this application note. Not sure if you have gone through the DDR configuration. There's an app note written to specifically address this.
Yeah, there is a readme in the top of that. I read that one, and they specify there are some which registers you need to be taken care. Those things I gone, but then I also there is multiple people asked about the DDR tuning. But the only reply I seen is like driver you will take care, but what is it set finally, whether it is optimized way or not, that I am not getting. Because what the problem I am facing is, if I put the same configuration for a 10 boards, in that I feel some boards will be optimized and it is not so efficient, I feel. Or if I want to tell my DDR vendor, okay, this is the way we optimized and we will share with you the result, means I am not getting anything out of that. So how DDR tuning is taken care and how I can share the tuning, is any option for me?
I think the first thumb rule is to use the tool to get the register configuration that it dumps, and then integrate that to whatever code base that you're using, either RTOS SBL or
Linux
R5 SPL.
Yeah.
Then rest of the things should be taken care by the R5 GDR driver.
Yeah, I agree, but tuning, how it will finally, okay, it will be some, okay, if I make a little bit deviation from the standard one also, it will take to, it is just like a starting point and run its own algorithm and set best. That is what I understood from that conversations from TA forum, or that is the reason. But what is set finally is I am not getting. Even that question is asked in T2E. Yeah, I didn't get the proper answer.
Okay, probably we can again highlight that we'll respond with with some real answers from our DDR expert.
Okay.
We'll take that.
Okay.
Yeah. That's what I told, and I think there are more detailed questions that we'll take on the detail.
Okay.
Yeah, thank you.
Any further questions?
Very basic question. Like from morning, I'm seeing like the TI autos is not mentioned. So what takes over? Like pre-autos is more trending than TI autos. Like why?
What is the question, please?
Like we have like Texas Instrument has its own autos, right?
Yeah.
Like you people didn't mention anything about that from morning.
Okay.
Pre-autos is in the picture.
Yeah. So it's very good question. So we had our own TISys BIOS, and if you see our, let's say previous devices, it was all supporting, the TISys BIOS. So I would say in 2020, beginning of 2021, we made a conscious choice. And if you see my MC Plus SDK slide, right, one of the pillar was focused on the open source ecosystem. So the idea is, right, basically utilizing the open source FreeRTOS, because if you see that way, then we can utilize, because the safety is one concern for our microcontroller, right, for the RTOS cores. So we could utilize the open source community or open source partners to get the features or functionality which is needed. And also to enable easier migration, easier portability, right, because typically FreeRTOS is very widely known operating system. So why to bring a own proprietary operating system, right, if there is existing proven operating system out there in the open source community. So that was the basically, a conscious decision we made. So after the 2021, any device which came, we are pretty much on the FreeRTOS thing. There are additional operating system enabled with the help of our partners, but no TISys BIOS or our own proprietary operating systems. Good question though. Thank you.
Thank you.